Today, we're going to be talking about how factoring is used in geometry problems. So our objective is that we will be able to use factoring to solve real-world problems. So in our first example, determine the side lengths of the rectangle below given that the area of the rectangle is 96 inches squared. Now you can either look it up on your formula sheet or you might remember that the area of a rectangle equals the length times the width. Here's our length. Here's our width. Our area we know is 96. Our length is x minus 3. And our width is x plus 1. So the first thing we want to do is get rid of our parentheses by double distributing. Distribute the x to both terms. Distribute the negative 3 to both terms. So if we do that, I'm going to bring down my 96. That would equal x squared plus 1x minus 3x minus 3. Now I'm going to combine like terms. And then remember with factoring, we need our equation equal to 0. And to do that, I'm going to subtract 96 on both sides. So now I have 0 equals x squared minus 2x minus 99. Now if you recall from our factoring video, there's a 1 here and negative 99, which will give us negative 99. And we need two things that multiply to negative 99 and add up to negative 2. Well, 99, I know that's a factor of 9 and 11. Those are 2 apart, so if I make the 11 negative, those will add up to negative 2. Bring down my ax squared term, split my bx term into plus 9x and minus 11x. Bring down the c term. Group the first two, plus a negative, and group the second two. The first two have an x in common, and I'm left with x plus 9. Second two have a negative 11 in common, which will leave me with x plus 9. Bring down my equal 0. So 0 equals x minus 11 and x plus 9. Set those equal to 0 and solve, we would get that x equals 11 and negative 9. And if you need help with this factoring part, make sure you go back and watch your video on factoring a trinomial. So now that we have these possible x values, there's something to think about because this is talking about side lengths in real life. If I put a negative 9 in here, I would negative 9 plus 1. That would give me negative 8 for the length of the side. It does not make sense to have a length of negative 8, and therefore negative 9 is not a usable answer. It's called an extraneous solution, and we don't want that. So x equals 11 is the only possibility. So if I plug in 11 for the x here, plus 1, that tells me that AB has a length of 12. For BC, if I plug in 12 here, 12 minus 3, that gives me a length of 9. My bad, I plugged in the wrong number. Our x was 11. That's what we're plugging in. Plug in 11 here. 11 minus 3 gives us 8 for BC. But what's CD? If you recall, we are dealing with a rectangle. And rectangles, the opposite sides, are congruent. So CD is going to have the same length as AB. And AD will have the same length as BC. From this, we can also conclude that this picture is not drawn to scale because this side is 12 and this side is 8. Let's look at another example. This time we're dealing with a triangle, a right triangle to be more specific. Given the right triangle below, solve for x. So across from the right angle, that's our hypotenuse. That's going to be our C, A, and B. So a squared would be x plus 2 squared plus x squared equals the square root of 10 squared. Now, think back. What does it mean to square something? Hopefully you said that it means to multiply it by itself. So here we have to multiply x plus 2 times x plus 2. So we have to double distribute like we did in the last problem. We get x squared plus 2x plus 2x plus 4. I'm going to bring down my other terms. And now we can do some simplifying. Let's combine all the like terms. We've got an x squared and an x squared, which gives me 2x squared, 2x, and 2x gives me 4x. Bring down my plus 4. If we square a square root, they undo each other, so this will just simplify to be 10. Now remember, we need our equation to equal 0 in order to factor, so I'm going to subtract the 10. And what do you notice about all three terms? They're all divisible by 2, so I'm going to factor that out. I'd be left with x squared plus 2x minus 3 equals 0. Multiply my a and my c, I get negative 3. I need two numbers that multiply to give me negative 3 and add up to 2. Well, the only factors of 3 are 1 and 3, and since it's negative, we know one of them will be negative. Since we want a positive 2, we're going to need a negative 1. So I'll have x squared minus 1x plus 3x minus 3. Group the first two, group the second two. These both have an x. We'll be left with x minus 1. These both have a 3. And we'll be left with x minus 1. So our factors are 2, x minus 1, and x plus 3 equals 0. 2 can't equal 0, so we don't have to worry about that one. If we set x minus 1 equal to 0, we'll get 1. If we set x plus 3 equal to 0, we'll get negative 3. Like in the last problem, since we have a side length of just x, it doesn't make sense to have an x that's negative 3. We can't use that as a side length. So our only x value is 1. So x equals 1. And then what if we wanted to find the perimeter? Perimeter, remember, means add up all the sides. So x would be 1. This would be 1 plus 2, which would become 3, and 10. Or sorry, square root of 10. 3 plus 1 plus the square root of 10. And if you type that in your calculator, we get that the perimeter is approximately 7.16. And it didn't have any units, so you could just write units or you could just leave it. Let's look at some problems involving circles. If you recall, we multiply the pieces of the segments together, and that'll equal the product of the other pieces. So I'm going to multiply x minus 9 times x minus 13, and that should equal 21 times 32. So double distribute, x squared minus 13x minus 9x plus 117 equals 672. So we get x squared minus 21x, minus 22x, and we need to make this 0, so I'm going to go ahead and subtract this in the same step as well. Minus 555 equals 0. So 1 times negative 150, or sorry, negative 555. We need factors of that. Well, we know it's divisible by 5, but that's 111. So let's try dividing it by 25. Nope. What if we try 15? Because that's also divisible by, we know if it ends in a 5, it'll be divisible by something that ends in a 5. Yep, we divide it by 15, then we get negative 37, and those will add up to negative 22. So x squared plus 15x minus 37x minus 555 equals 0. These two both have an x, which leaves me with x plus 15. Since I know there's not going to be a coefficient in front of the x in the parentheses, that gives me a hint that both of these are divisible by negative 37. Factor that out and get x plus 15 equals 0. So my factors are x plus 15 and x minus 37 equals 0. So x equals negative 15 and positive 37. Now, if I plug 37 in for both of these x's, I get positive values. But if I plug in a negative 15, it's not going to work. So again, that's an extraneous solution. And we have x equals 37. That's my one final answer. And for our final example, we've got a line tangent to a circle and a secant with a circle. So we're going to square the tangent piece. And then for this part, we do the outside times the entire thing, which would be y plus 30. All right, so we're going to distribute the y. So I'd have y squared plus 30y. 20 squared is 400. We need our equation equal to 0. So 0 equals y squared plus 30y. The 400 doesn't combine with any other like terms, so we're going to put that on the end. 1 times negative 400 is negative 400. And we need two things that will multiply to 400 and add up to 30. Sorry, to multiply to negative 400. And that would be positive 40 and negative 10. So 0 equals y squared plus 40y minus 10y minus 400. Group the first two. I can factor out a y and be left with y plus 40. The second 2, I can factor out a negative 10 and be left with y plus 40. That gives me factors of y plus 40 and y minus 10. If we set those equal to 0 and solve, we would get y equals negative 40 and positive 10. But y is our length out here, which can't be negative. So we get that y equals 10. Don't forget to write your summary, and I'll see you in